Alright, in this video we're going to be looking at Unit 1B and kind of a continuation of looking at arguments and logic. This time we're looking at the idea of propositions and truth values. And so when we talk about propositions, we're talking about proper arguments. And the building blocks of arguments we're going to call propositions, and these are statements that make or propose a claim that can be either true or false. It has one or the other. And a proposition must have the structure of a complete sentence and make a distinct assertion or denial. Okay, so it has to be very clear whether something is true or false in making a statement. So here's a couple of examples. We have Joan is sitting in the chair. That's a proposition. It's a complete sentence that makes an assertion. She's either in the chair or she's not sitting in the chair. Okay, the next one, I did not take the pen, is a proposition because it's a complete sentence that makes a denial. Okay, I did not take the pen, that's either true or false. The next one, are you going to the store, is not a proposition, that's a question. It doesn't assert or deny anything, it's asking a question. So any type of question is not a proposition. Okay, 3 miles south of here is not a proposition because it doesn't make a claim of any kind and it's not a complete sentence. And then lastly, the mathematical equation 7 plus 9 equals 2 is a proposition. Even though it's false, it's still a proposition. Because you can read it as a complete sentence, it is a distinct claim. Even though it's false, it's still a proposition, because remember, a proposition makes a claim, which is an assertion or denial that may either be true or false. So let's look at and determine if the following statements are propositions, and kind of give an explanation as to why. So on 13 here it says the sky is the limit. Okay, that is a proposition. Okay, because we are making an assertion that the sky is the limit. It could either be true or it could be false. Definitely depending on your situation. But in this case, the sky is not the limit. We know that things go beyond the sky. So this would be a false proposition, but it definitely takes on an assertion in a complete sentence form. Number 18, the deposed leader was corrupt. Okay, that is also a proposition. Leader could be corrupt or could not be, but it is a full, complete sentence. It is a proposition, and again, the truth value there, it depends on the leader that you're looking at, but that definitely is a proposition. Now, just one thing again to keep in mind, as I mentioned up here, right here, any question that you see is not a proposition. Okay, a question is never a proposition. Okay, now we're going to look at this idea called a negation, or in other words, opposites. So when we're looking at the logical opposite of proposition, that is called the negation. For example, when we looked at Joan is sitting in the chair, the negation of that is Joan is not sitting in the chair. Or the negation of 7 plus 9 equals 2 is 7 plus 9 does not equal 2. And so when we start to look at these propositions, we may begin to label them as proposition P and Q. Those tend to be the most popular, but P is usually our first proposition. And so when we look at the letter P, then its negation would be not P. Sometimes it's written as this little swirly line P. Sometimes it's also written as P with a little apostrophe. Different ways to represent it, or as you can see down here, you can just write out this phrase, not P. Okay. Now negations are propositions because they have the same structure, and they can either be true or false depending on the proposition you're looking at. Now again, we've mentioned that the proposition has a truth value. It's either true or it's false, so we'll be writing T's and F's. Okay, now if the proposition is true, the negation must be false and vice versa. And what we do, we try and represent all the possibilities of a proposition in what we call a truth table. Okay, and that table, it just has a row for each possible set of truth values. And so we're going to be looking at something like this. This little table right here is a truth table. So we have the proposition P, and the first row is if P is true, then not P is false. If P is false, then not P is true. Okay, so that's how you would read the truth table. And so you can see all those formal definitions that I have right here. But again, that's just the basic idea of propositions, the negations, which are opposites, and their definitions. Okay, let's look at a couple things with negations, and then we'll jump into, we'll end this video and jump into a part 2. Okay, we want to write the negation of the given proposition and then state the truth value of the original proposition and the negation. So Peru is in the northern hemisphere. Okay, so in the negation would just be that Peru is not in the northern hemisphere. Okay, I'll just abbreviate that. So we have, this is our proposition P here. I'll change colors for this. And then this is our proposition not P. Again, you can write that out if you'd like to. And P, where Peru is in the northern hemisphere, that is false. But not P, Peru is not in the northern hemisphere, that is true, because Peru is actually in the southern hemisphere. Okay, now one more thing we'll look at in this video is when we have multiple negations. And these can get a little bit confusing when you have several negations, so you have to read them carefully. So we're going to read through this statement which contains multiple negations, and then try and answer the question that follows. So it says, the senator opposes overriding the governor's veto of the bill. So opposes overriding and vetoing a bill. Okay, so now hopefully you understand the idea of a veto. That just means that a governor, it's passed by a body of legislation, and then the governor is an executive branch that can either accept or reject the bill, and a veto is a rejection of the bill. So we have the senator opposes, so he is not for overriding the governor's veto of the bill. So he doesn't want to override the governor's veto, which in other words means he wants the governor's veto to stay in place. So that would mean that the senator, if he wants the veto to stay in place, that means the senator does not support the bill, because he again wants that veto to remain in place, because he opposes overriding the veto, which means he's in support of keeping the veto. So again, multiple negations sometimes can be a little bit confusing, so you have to take a moment and think through those. So hopefully this helps out, and we'll continue in part 2.